5.5 covers the derivative of y equals tan x. So what we're going to do in example 1 is we're going to find the derivative of y equals tan x, but we're going to find the derivative the long way. We're going to find it by subbing in sine x over cos x for that tan x. So if you ever forget how to derive tan x, like on a test or on an exam or anything, you can always do this at the side of your paper. So what we're going to do is we're going to use product rule. So we're going to write this as sine x and then cos. The negative 1 should actually be here, negative 1x. Okay. So u prime v plus uv prime. Okay. Derivative of the first thing is just cos x. Derivative or times the second thing as it is. So cos negative 1x. And then we have plus the first thing as it is, which is sine x, times the derivative of the second thing. So bring that negative 1 down, times cos to the negative 2x. Then we're going to do the derivative of cos x, which is negative sine x. Okay, cos x over cos x, that's what this is, and that's just 1. Okay, now we have negative 1. We have sine x times negative sine x, so another negative, which will be positive. So let's just scratch that out. So in the numerator, we have sine squared x, and then this cos squared x goes into the denominator. Okay, so what are we left with? We're left with 1 plus sine squared x over cos squared x. But we can just rewrite that as 1 plus, and what's sine squared over cos squared? Well, that's just tan squared, of course. Tan squared x. But we know that 1 plus tan squared x is actually, we can just rewrite that as secant squared x. Okay, so the derivative of tan, so y prime equals secant squared x. Okay, so we have this written here. So the derivative of y equals tan x is just secant squared x. Okay, and now if we have tan of a function, we're going to write secant squared of that function times the derivative of that function. Okay, so example 2, let's determine the dy by dx of this function. So tan of this function. So we know that it's going to be secant squared of that function, secant squared of x squared plus 3x. Now we're going to multiply it by the derivative of what's in here, so 2x plus 3. And that's it. Hopefully these ones fit. Determine the derivative dy by dx for this function. So let's bring that 4 down here. We have 4, write the bracket as it is, sine x plus tan x to the 3. Then we're going to multiply by what's in the derivative of the function. So derivative of sine x is negative cos x. Derivative of tan is just secant squared. And that's it. We can leave that as it is. You can also reverse these two so that the negative is later on in the bracket. Okay, now example 4, determine dy by dx for this one. Dy by dx. Okay, I'm going to do product rule because it's x times this function. Okay, derivative of the first is just 1 times the second as it is, plus the first thing as it is, times the derivative of the second thing. So the derivative of tan 2x minus 1 is secant squared, 2x minus 1, and we're going to multiply that by the derivative of what's in that function. Okay, if you want to rewrite this, bring that 2 out front, and it's rewritten like this.